Welcome you all in my channel Chemistry the Mystery of Molecules. So I am Tanmay. So today I shall discuss an important topic which is dehydration of alcohol for the preparation of alkene. Okay. So alcohol in presence of mainly acid and under heating it produces alkene, and actually it produces along with this one molecule of water. Okay. So this is the reaction. And in this process, generally used acid is sulfuric acid, phosphoric acid, or in some cases not actually acid, mainly alumina. It acts as a solid support catalyst for the conversion of that alcohol to alkene. Okay, the difference is in alcohol to this sulfuric acid, phosphoric acid require a little bit less temperature, but alumina needed around 350 to 400 degrees centigrade, like that much high temperature, and it flows over this bed of this alumina, means alcohol, to produce the alkene. And why alkene is important? For example, if you consider the dehydration of ethanol to ethylene. Ethanol is a bio-derived product, fermentation produces alcohol from carbohydrate, fermentation, and right now every country is producing trying to prepare second generation, third generation ethanol from waste. I shall make a dedicated video on that later on. So this is fermentation produces ethylene. Okay. Now this ethylene is used for preparation of polyethylene, and that is a plastic material used regularly. So this is a very important material. But for the preparation of this ethylene, it is essential to have high temperature. Why? Because here one molecule of water is produced and the process is acid catalyzed. If you reduce the temperature from 170 degree to 140 degree, like lower temperature like 140 degree, then what it produces? This produces diethyl ether. Okay. Actually, then what happens? Two molecules of ethanol removes one molecule of water to produce this, and here one molecule of alcohol giving up one molecule of water to produce alkene. So from here you can consider delta G equal to delta H minus T delta S. From that equation, if increasing temperature and increasing temperature will favor this side, means entropically, because here one molecule produces two molecule and here two molecule produces three molecules. So entropically this is favorable. So if temperature is increased, then overall this process will be more favorable. Okay. So this is the main factor. Right now we will discuss what is the mechanism. So today mainly we discuss about the mechanism. Okay. And we know this sulfuric acid is a very strong acid because it removes one proton and produces this O minus and H plus, and this O minus is resonance stabilized by 3 group, and actually in compared to sulfuric acid it is generally more used that potassium bisulfate, because potassium bisulfate could be considered as solid acid. Means instead of sulfuric acid, potassium bisulfate KHSO4 is a better choice. Why? Because one side it's a solid and it's a salt, so easy to carry. Never confuse this with potassium persulfate. That's a different reagent. KHSO4, potassium bisulfate. Okay. So this is, and right now we will discuss about the mechanism. What happens? This alcohol in presence of acid produces protonated species. Okay, so overall the formal charge is on oxygen. If it is protonated, then it becomes a good living group under acidic condition, because OH is a good living group, and H2 is a neutral molecule, so it will leave to produce a carbocation. This plus water. So carbocation, and this carbocation eliminates another molecule of hydrogen. For example, this. Somebody abstract this to produce ethylene. Now who will abstract this? This proton could be abstracted by another molecule of alcohol or the corresponding means the anion generated from the acid itself. Okay, so in this context, along with sulfuric acid, phosphoric acid is a better choice. Why? Because sulfuric acid sometimes results in charring, means carbonization of a material, but phosphoric acid don't show that type of property. That's why phosphoric acid is preferred over sulfuric acid. Okay. Okay. So till now, up to this discussion, we have observed that this material produces carbocation as an intermediate. So if it produces carbocation as an intermediate, then there is a tendency that a tertiary alcohol and a secondary alcohol and a primary alcohol, if we compare, this will be faster rate than this. So because the corresponding carbocation tertiary is more stable than secondary than primary. First point. Second, if there is not that kind of chance, for example, let's consider this. CH2OH, then it will produce a carbocation which is a primary. Primary means this, and that will undergo rearrangement, which is the usual property, and in this way primary will be converted into a tertiary, means that carbocation will be this. Okay, so in this way carbocation undergo rearrangement. One factor is proved. Okay. Second factor, that this carbocation is produced, okay, fine, and ultimate product is ethylene. And another thing, generally we observe that this process is done under acidic condition, so it produces alkene, and in the heating condition this alkene goes out of the system, means it distill off, because alcohol has hydrogen bonding option, so hydrogen bonding increases its boiling point, but here no hydrogen bonding, so it distill off. Okay, fine. So now we will discuss about the alkene preparation in details. How? For example, if we observe this RCH2CH, this produces CH2OH, this produces an alkene. Alkene means this one. Let's introduce. If we use, in case of this, propanol or ethanol. Propanol means 3, here one CH3, no problem, we will get this propanol. And ethylene, ethanol, ethylene, no problem. But if we take higher alcohol, for example, let's take butanol, CH2CH3, then what will be the product? It is expected that it will produce a mixture of product. What do I mean mixture of product? Mixture of product means this N-butyl carbocation will be produced. CH3, CH2, CH2 and CH2. This is a carbocation. So it is expected that it will abstract proton, means hydrogen, from here to produce this 1-butene. But in reality, along with 1-butene, another material is produced, that is 2-butene. Question: how? So how this double bond migrates? So never be confused that here carbocation is shifting. Instead of that, there is another option also. What? The produced, for example, let's consider it produces 1-butene, because under the heating thermal condition alkene is produced. These 1-butene can undergo further protonation. One possible chance is that hydride market, I agree, but this should not be the only possibility. This can undergo acidification, means protonation, to produce this or this. So two options are possible, that this will produce a primary or a secondary, and this secondary may further undergo elimination to produce this. The details mechanism I'll explain. So this is the fact, And another thing, alkene, I in my previous video have explained, alkene has a electron cloud, pi electron cloud, lumpy, loosely bound. So it could be protonated by the acid. Okay, fine. So now question, how this process is happening? Actually, this process happens through a transition state, which is, we can say, alkene type. Okay, transition state is alkene type. What do I mean? If we consider this as an energy axis, and this is the intermediate. This is, for example, this is for 2-butene, and this is for 1-butene. 1-butene, just number. Okay. And if this produces 2-butene, it's more stable. So its energy, let's consider here, 2-butene. So this one is this. And if this produces 1, then it's here. Okay, this is 1-butene. Now question, why generally we observe that this is produced, not this? Because it should be produced during the reaction, but it further converted into this. Why? Because this is the primary, secondary carbocation. Based on their stability, I have given this. Secondly, this is the energy of activation for the conversion of this carbocation to alkene, and this is a transition state. If we consider the transition state here, the transition state is actually resembles to this butene. What do I mean? This is CH3, this is CH, this is CH, CH3. I am not going to cis trans, I will explain later. So it is a carbocation, so it eliminates one hydrogen. So this hydrogen is eliminating, so it should be dotted. So the transition state is incipient alkene type. Incipient alkene type, and it's a substituted alkene, and this transition state is also incipient alkene type, and that is actually CH, CH2, this is the hydrogen and this is the alkene. It is also an incipient alkene. It is a more substituted, this is a less substituted. Now what is the difference? Why the corresponding energy of activation? These E1, delta E1, and if we consider this is a delta E2, since it's for secondary, so delta E1 is greater than delta E2. Okay, this is the fact. Now why? Because the transition state is incipient alkene type. So like alkene, this transition state will be stabilized by hyperconjugation. The main factor is hyperconjugation. Okay, and this here you can see 3 plus 3, 6 hydrogens are involved in hyperconjugation, but here only 2 hydrogen, means these are involved in hyperconjugation. So more number of hydrogen involved in hyperconjugation, it will reflect the stability of the alkene. So that is the reason that this product is not obtained, this is obtained. And what happened? It produced, all the reactions are reversible in nature. For example, dehydration to produce carbocation, that carbocation to produce that alkene produces the further these two 1-butene protonated to produce that secondary carbocation. All the processes have irreversible. And that's why, since the energy of activation for this process is lesser, ultimately, according to last real principle, this process shifted to this and ultimately produces the substituted alkene 2-butene. Okay? Okay. So this is. Now, if we consider what will be the product, E or Z. Okay? Means actually we have proved till now that this process is regioselective. Regioselective. What do I mean? Means the region or position of the double bond is more substituted. This is regioselective. Now question will be, it is stereoselective. Means cis or trans or E or Z, whatever, it's a nomenclature. So cis or trans. So question, how? Now you have to check in that case, because if it is, then we have understood that it will be secondary alkene, means more substituted. So let's screen this part. Now here everything is secondary carbocation. Now there is a chance that it could be cis or it could be trans. Cis means this side, same side methyl. Sorry, let's consider this as a trans. This, and let's consider this as a cis. Here carbocation and here hydrogen. Okay, this is another hydrogen, this is another hydrogen. So this is, so here the product will be ultimately cis-2-butene. Cis-2-butene. And here the product will be trans-2-butene. Now, see, here that in the transition state, this transition state is incipient alkene type I told. So here these two methyl group are apart from each other. Means the steric hindrance is less here. But here the steric hindrance is more. Okay? So that is the reason. Because in transition state also some steric hindrance is there. Another thing, that these hindrance don't make anything unstable. Please, before commenting this statement carefully. This steric repulsion don't make anything unstable. It reduce stability but not increase instability. Because actually molecule is stable, otherwise how why it will form, or it will be stable in room temperature. But it reduces stability. This, that's why corresponding energy of activation for the preparation of cis-2-butene is higher. So that, and trans is lesser because this steric interaction is not absent here. So that is the reason why this trans-2-butene is produced instead of this. So generally it is preferred that dehydration of alcohol will produce trans-alkene. Okay, so then we have made one thing, first regioselective and then stereoselective. So dehydration of alkene is one point regioselective and second point it is stereoselective. So this is the end of the video. So if you like my teaching, please give a like and share this video among your friends such that many people would be benefited. Subscribe my channel Chemistry the Mystery of Molecule and please press the bell icon to get the notification of every single video I upload. So see you in my next video.